So first of all, let's remember how circles work. Geometrically, you start with a point, and then you measure in every single direction the same distance from that point. A good way to draw a circle might be to put a thumbtack right there at the center and tie a pencil to a string and just pull the pencil around and around in a circle. And we call it around and around a circle because you draw a circle. Now, ellipses are a different conic section. The main difference is, instead of slicing the cone perfectly horizontally like you do when you get a circle, for an ellipse you slice at a diagonal and you get a sort of stretched out circle that goes sideways. So for drawing it, the idea is that it's like a circle, except you draw it with 2 points. And you might not quite connect what that means, what you actually do to draw it, but the idea is, instead of tying a string around 1 point and pulling it in all directions around in a circular pattern, what you do instead is you tie a string around 2 points and you pull it around and around and around. And if you actually sit down and do this once with actual thumbtacks, an actual string, and an actual pencil, it'll help train your brain to think about the way an ellipse is supposed to look. Those 2 points, of course, are going to be really important when we're graphing these ellipse things. And those 2 points are called foci. And finding them is going to be one of the main challenges of working with ellipses. So, let's talk about the actual equation that we get for this. And it starts with the circle equation we had from section 13.1. So with a circle equation, you have x squared plus y squared equals r squared. But the problem with that equation is there's only a single place to plug in a number for r, which means you really can only have a single r. But as you can see in the picture of an ellipse, it's longer in one direction and shorter in a different direction. So you have to be able to have 2 different numbers for r. And the trick is to divide the whole equation by r squared, which doesn't seem like it accomplishes much until you realize now you got 2 places where r exists. And if you think a little creatively, isn't it possible they could be 2 different numbers in the equation? Of course. So the equation we're going to be working with when we work with ellipses, it's going to look like this. And perhaps the most important part of the equation is to be absolutely certain you've got 1 over on the other side. If the number over there is not 1, your equation is not in the right form, and you shouldn't try to move on to anything else. So, for example, if your challenge is to graph an equation like this, you see that 36 over on the right-hand side, that's got to be fixed. And the way you fix it is really just what I did above in creating the equation in the first place. Divide everything by 36. The equation we get out of this, once you're done reducing, is x squared over 4, y squared over 9 equals 1. Here's what you need to get out of this equation. You need to figure out what a is, and you need to figure out what b is. And this works just like when you're working with the radius of a circle. You have to take a square root. So a is not 4, a is 2. B isn't 9, B is 3. And the vocabulary I use to refer to A and B, this is not standard vocabulary. It's not anything that you're going to see in any textbook ever, but I think it'll help you when you're actually drawing the picture. What I do is I call A the horizontal radius, and as you might imagine, I call B the vertical radius. And that's not really proper vocabulary because radius is supposed to only be a word you use with circles. But in this case, what you're going to do with those numbers is pretty much what you would do with circles. You're just going to use different numbers in different directions. So if the horizontal radius is 2, then that means you're going to go 2 to the left and 2 to the right, and mark there and there some points that would normally be on a circle, but here they'll be on an ellipse. And if your vertical radius is 3, you're going to mark up 3, and you're going to mark down 3. So it works just like drawing a circle, with the added little twist that left and right might not be the same as up and down. Then you connect the dots with a nice smooth curve, just like you would with circles. Don't make it some sort of a diamond shape. Remember, I'm not going to give full credit if somebody doesn't even try to draw the thing sort of curvy. And then there's one last bit, and this is really the main difference between circles and ellipses, because everything up to this point is pretty much like what you would do when you're drawing a circle. So the new thing now is you have to be able to figure out where are the foci. And based on what we saw with the drawing, with the pencil and the string, you can tell, since this ellipse points up and down, it's taller than it is wide, that the foci have to be somewhere in this vertical direction, somewhere on the y-axis here. To figure out exactly where they are, the equation we're going to have to use is this. And please be aware that this does come in two varieties, because sometimes B is bigger than A, and sometimes A is bigger than B. Some ellipses are tall, and some ellipses are wide. So depending on whether you have a tall one or a wide one, make sure you're doing the subtraction in the sensible order. So it's really pretty much common sense. If you made the mistake of saying 4 minus 9, you should catch on pretty quick that, oops, I have them in the wrong order. So make sure you subtract the small one from the big one. And one of the kind of unfortunate things about working with ellipses is there's no guarantee that C is going to come out to be some nice familiar number. And if you're talking about square root of 5 or something like that that's not an easy number to recognize, the best you can really do is type it into a calculator and think about approximately how big that is. Square root of 5 is about 2.2 on a calculator. So here we're going to put our foci 2.2 up and 2.2 down because this is a tall ellipse. If this ellipse had been wide instead of tall, of course you'd be putting those foci left and right. All right, let's do another example just to make sure you consider all the different possible twists and turns that can happen with this kind of problem. So let's say we're taking a look at a problem like this. There's an extra complication here. In order to get it equal to 1, it can't possibly start with a 0 on the other side. What are you supposed to do? Divide by 0? You're not allowed to divide by 0. So the first step in most ellipse problems is to isolate the variables on one side and the number on the other side. Then you can divide both sides by whatever it takes to make it come out equal to 1. Then you reduce your fractions, and you figure out A and B. So here, A is 4, and B is, another square root. And again, this is something you need to get familiar with. It's going to happen. The vertical radius here is square root of 10. Square root of 10 is not something that's real easy to think about. It's probably better to think about it in decimal form. So you grab your calculator, you type it into the calculator. Square root of 10, it's around 3.2. So when you're graphing this ellipse, you go in the vertical direction a little bit more than 3. But other than that, we're going to draw our ellipse pretty much the same way we did the previous one. The horizontal radius is 4, so we go 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the right, and there's our horizontal points. Our vertical radius is square root of 10, which in our mind we're thinking 3.2. So we go square root of 10 up, which about there, square root of 10 down, so about there. And then you make a nice smooth curve. And as you can see in this case, this one is almost a circle. Square root of 10 and 4, they're a little bit different, but if you just took a quick glance at that picture, you might not even notice the difference. Some ellipses are really close to being circles. Next, figure out where the focus points are. So to figure out the foci, we're again going to do c squared equals, and in this case, a squared is bigger than b squared, so make sure you're always subtracting in the logical order. So c comes out to be square root of 6, and again, that's no good. We're going to turn it into a decimal so that we can approximate about where it's at. Square root of 6 is almost 2.5. It's like 2.4 or something. And here, notice which direction this ellipse is pointing, which part of it is longer. This ellipse, A, is bigger than B. This ellipse has more distance horizontally than it does vertically. So the focus points have to go horizontally. The way you figure out whether they're marked on the x-axis or the y-axis is simply about which direction is bigger. Don't overthink it. It's not some complicated formula. It's just, it's bigger this direction, so I put my marks in this direction.